Wow, I've never crashed into the ceiling before, but there's what happened. It kinda took off into the ceiling and now it's still in the ceiling. This is the flame wheel that you just saw in the overhead. How did it get there? You can sort of see there's two broken props. That's about all the damage was done. I'll fix that, but let me kind of explain how it got to this point. We'll plug in USB-C to the H743 wing that's inside the flame wheel. And if we look up on the screen, we connect. There we go. And what we're running here is Arducopter 4.0.7, the current stable version, on the current stable version of Mission Planner, which updated in the last couple of weeks to 1.3.75. So there's the Arducopter setup of the flame wheel that we're to the point of PID tuning with Arducopter. Now, I've sat here in the past couple of days and made all sorts of videos about how I wanted to fly this on INav in the same day, and all the problems I was coming up with. You saw one was the CAN bus. Let me go ahead and get out of this, and we'll go to INav. I'll need to put the flame wheel in DFU mode. Okay, back up on the screen. We are now in DFU mode. We're going to go with the firmware that has just came out from INav, which is the Maytag H743 wing, and its current stable version, full chip arrays. Again, when we load this firmware from the internet and it pops up the release notes, you might have seen I talked about this CAN bus is not supported problem that kind of stopped me. I'm going to go ahead and click flash firmware here, let it start erasing and then flashing and then verifying. INav 3.0.1. We're going to make this into an INav copter. Okay. You saw my video where I was complaining about no CAN bus support. I ended up opening up the top of the flame wheel, putting the connector on so I could run this M8Q CAN GPS compass from UART, which it's on now. You can see that one's labeled. This one's labeled CAN bus and can go in that center when I want to run it under Arducopter and CAN bus, or whenever INav supports CAN bus. So that was the first problem I ran into, trying to be able to flash this in the field and run INav on it right after flying it with Arducopter. So I bit the bullet, went in, put the second cable on so I could run the GPS either CAN bus or UART, whichever one I choose. Again, UART, you can see it's sitting here. It's actually locked up satellites because the UART 6 and 2 on the H743 powers up with USB power, whereas the CAN bus doesn't power up until you put battery power on it here. That's why I like this setup so much, because in the field I could be doing this, connecting satellites while I get all my other stuff ready to go. Anyway, that was the first problem I ran into flying this thing in INav right after flying it with Arducopter. Let me pull out this programming successful down at the bottom. Pull this out, let it get a complete hard reboot. Then we'll come up here and connect to it. Okay. After firmware flash, you have to sort of give it a little bit of idea what's going on. This is not a mini quad. The flame wheel is far from a mini quad. It's over 3 feet across. But it's not an airplane with a tail or without a tail. It's not a rover or a boat. Just not going to do either one of these. I'll just go ahead and give it this. So now if we look down at the, it will reboot right after doing that, by the way. Unlike beta, oops, there we go, reboot. Now you can see here, if I raise this up, my accelerometers are already working fine. No problem with them whatsoever. Come in here to calibration. I need to do my accelerometer calibration and my compass calibration. In the mixer here, I need to change this from a quad to a Hexa X. This matches the flame wheel. Load and apply. It reboots, restarts, reconnects, and here we are. Now then, I went out and looked at the frame geometry for Arducopter. These are 6 auxiliary ports on a Pixhawk. We won't discuss those at all right now. These are your normal RC outputs 1 through 8. This is an S-bus output. This is an RC input, which is PPM S-bus. So you plug in the motors, motor 1, 2, 3, 4, 5, and 6, according to a plan. Motor order diagram. They're right down here. Green, by the way, is clockwise. Blue circles are counterclockwise. So we come down through here and we get to the Hexa. We have 2 choices. We have the Hexa X and the Hexa Plus. The Plus is where it's oriented so it has a prop front and back. Generally in FPV we do this at the Hexa X because we frequently have a camera. I always seem to be looking through these props, but there's ways around that, but it's much easier than with a prop dead center in the middle. So Hexa X is the way we do it. If we look at INav, comparing those two, let me see if I can lay those up somehow, overlay them. Oops, or get them where we can see them both. Okay, come on. Just watch my hands, can't do a thing with them. Okay, so right off the bat I can see the motors are numbered differently. So the 1 through 6 connection on the flight controller is not the same. That's a bad thing. Let's look at the others real quick. We can see that this right rear motor is counterclockwise, left rear motor is clockwise. That checks. This one is clockwise, check. This one is counterclockwise, counterclockwise, check. This one here is counterclockwise, counterclockwise, check. Right here is clockwise, clockwise, check. So that all works out. The frame geometry as far as the motor directions is perfect. But the problem here is, if we go back to this real quick, this is the motoring on the Arducopter, and the way they're plugged into the RC channels 1 through 6 is 1, 2, 3, 4, 5, and 6. Whereas on INav it's 1, 2, 3, 4, 5, 6. Big bummer. But I'm persistent, if nothing else. And I got to checking out some things and learned some things. On the Quad X right now, I hope they do this someday for the Hexes, you can load a mixer wizard right here and come in here for the position of the motor, tell it which motor you're talking about. You can do some crazy things here. That's motor 4, and then it's 2, and then it's 1, and then it's 3. And you could click apply and that would do that. Absolutely cool. Problem is this mixer wizard doesn't come up in any other configuration except for Quad X. Then you can do that. I'm just going to put that back correct for kicks and grins. Even though I didn't apply it. Make sure it stays. 1, 2, 3, 4. Yeah. So this is what I want. Hexa X. Load and apply again just for kicks and grins. Make sure it stays. So right then and there, I was going, oh my goodness gracious. I've got to take this top off down here on the bench. I've got to unplug all 6 of the motors, and then I've got to plug the motors back in. Instead of 1, 2, 3, 4, 5, 6, it's going to become 1, 2, 3, 4, 5, 6. That's nothing I'm going to do in the field. That's just not going to work for me. Well, I got to digging around on the internet, and I hope he doesn't kill me for this. I watched a Josh Bardwell video. He's from right across the mountain here in Knoxville, right on the other side of the state line from us here. I saw how Josh Bardwell was using the motor mixer to solve that problem, because he actually installed a 4-in-1 ESC upside down, which made it electronically upside down, and he needed to fix that in his quad, and he was mad enough to say that he did it up front. It was completely cool to me. As you've seen my smoke checks, you've seen me smoke stuff literally, and still publish the video. So I chose to do Josh Bardwell's idea, and I didn't see him flight test it. So with a grain of salt, I went ahead and did it. And what I did, if you look right here on the piece of paper I have in my hand, I took the values of the motor mix on the screen and I wrote them down 1 through 6. Then I came into the outputs here, did enable motors and servos, took my props off, and then clicked this, and then I put a battery on the platform, and then I used this to raise each motor, turn it up individually, make sure it was spinning in the right direction. Now this does stay with the same Arducopter motor setup We're not physically changing the ESC wires 1 through 6 on the controller, so that's never going to change. But in the logic, the programming, we're going to mash around this table. And the way we're going to do that, and I'll put a link to Josh Bardwell's video in the bottom of this because I proved he's correct. When I bring up one of those individual motors for position 1, I wrote down which position on the chart right above here, this layout of the frame geometry. I wrote down which motor spun. I wrote the number this down. So for 1, 5 position spun. For 2, it was 6. For 3, it was motor position 4. For 4, it was motor position 1. And 5 was motor position 2. And 6 was motor position 3. Now, armed with that information and this information, we're going to take whatever is in position 5. We're going to take this 1, -1, 0, and -1. We're going to move this value up into 1. 1's value is actually going to go to position 4. It's going to replace this parameter right here. So let me do that on the screen real quick, and I'll come back and we'll look at it. Now, this is how they are now. This is the way on the piece of paper. This is the way they were prior to me changing them. And on the screen is the way they are now. And that was according to Josh's video. Now, I'm getting the cart way in front of the horse, but I can tell you, I've flown it. It works. So once we've changed these around, well, I will say that it works in horizon mode, and it works after fashion in altitude hold mode, except for when it goes flying into the overhead. So there's that. So that overcomes the secondary problem of the motors aren't connected in the same order. Again, Arducopters 1, 2, what was it? 3, 4, 5, 6, something like that. And this is 1, 2, 3, 4, 5, 6. And I'm not going to open up the flame wheel in the field and switch those physical 6 wires from the E6 ESCs in a different order on the flight controller. I'm just not going to do that. But by doing this, I have essentially made it match Arducopter. And again, I've flown it. It does work. Let me replace these 2 props real quick, and we'll look at more of this. Does have a little wobble, not like it did, and it responds to the sticks in the direction it should. So there you go. I proved Josh Bardwell's logic. Now the next step would be to prove that it works in a controlled flight mode outside. Position, hold, return to home, something like that. But that proves the platform. If I put the compass in as a UART, I can fly it in Arducopter in the time it takes to change the battery. I can reflash it with INav 3.0.1, run in my diff, and fly it in INav in less than probably 5 minutes. And that's what I was after.